Welcome back to PyraPOD, and today I'd like to present a video to explaining the newest design for our PyraTENT. This is the PyraTENT. You see, this is the one made for those area that there's no freezing condition, okay, in the winter time. Okay, that the water never freeze. For example, in Africa, in certain area, yeah, it's warm during the winter time. Yeah, so for that, you don't have to use bubbles. Basically, you simply need a lot of water. So this design, as compared to the earlier design, that you can see quickly that we eliminate the gutter. Basically, we use pond liner, the green, part. We use pond liner to create a pond. Actually, it's a pond right underneath the PyraPOD. And we fill this pond with water. As you can see, the level inside is roughly here. Basically, it's slightly below the second step of the stair. Okay, so basically, there's 2 feet down under the ground, below the grade, and then 2 feet up, and the water is roughly 2/3 full. So yeah, and that's the situation. So this way we simply eliminate the need for a gutter, because the whole pond now is the gutter, and and also the double layer cavity, the boundary, the film. It's you can simply put a weight at the bottom, and so it just simply drip under the water. So everything is sealed by the water. In this case, the water never freeze, so we don't need to use bubbles as insulation. We can simply use the air within the double layer for insulation, and also have a pump, pump the water to the top and use water spray to create a mist water film on the top side of the inner layer. So that's what it is. And also we simplify the way we make the double layer. As you can see, this time we do not extend the 4 post all the way to the top. We keep it below the inner layer. So this way, the inner layer could be just like the outer layer. It's exactly the same, just a smaller coverage. And the only difference is that it has 4 wings, 4 wings on the edges. So with the wings, we attach that to the outer layer frame, the arc. Okay, so when we install it, simply we set up the inner frame first, and then there's a hole for the inner cover. So we just slip through that hole and then drop down the inner layer, and then we attach the outer arc, the frame. Yeah, so this way we simply wrap this the 4 wings onto the external arc. Okay, attach it, so create a tension, and then we finish with the outer layer. Outer layer is just a single layer fabric, and then we cover it like a hat. So that's how it is. Very simple. Make everything easier. and yeah, also the whole thing is it's very easy to make and install. Now I'm going to explain why we make the change. The change for the double layer cavity, the cover design. It just simplify, the making and the installation, right? But the bottom, I like to take some time to explain why we need to create a pond. What is critical? When we build any greenhouse, we never thought about creating a pond. I'm talking about the whole ground as a pond, right? No, because normally we grow with soil, right? But the problem with soil is, it never contained the water, right? When you water the soil, and then if it's open air, then the evaporation happens, right? You lose water through evaporation, but also the water sink, right? The water sink into the ground, and so because of that, you need lots of water to keep the soil moistured. So with water content, right? And that's the problem, and that create other problem as well. I'll just explain quickly with a few images I found, and show what I mean. So for example, this one I got it from this area. It's a researchgate.net. Okay, I found this article. It's called "A Review of Underground Soil and Night Sky as Passive Heat Sink." So basically, they talk about using the underground soil and the night sky as passive heat sink. Okay, so yeah, and then within this research paper, there's this is the download version of the paper. There's a picture showing the temperature profile for Las Vegas area. Okay, basically shows the 12-month temperature profile. In the wintertime, it's low, right? The temperature is about 0 degrees centigrade. And in the summertime, starting from June, and then we see the temperature is is as high as 38 or 39. So roughly, we see the temperature sway from 0 to 30, 38, and around that area. And so it is common sense. It has something to do with the angle of the sun. In summertime, the sun is above the head, right? But in the wintertime, the sun shine through the lower degree. So because of that, we get a higher solar gain in the summertime and a lower solar gain in the wintertime. I'm talking about the Earth. I'm talking about the ambient air situation. Okay, so this picture shows clearly that the in the summertime, right, it's high, and the wintertime is low. So we see a sine wave. This is the blue line, solid line, right? Shows air temperature, right? But once you measure the soil temperature in the same area, you get very it's a curve also, has something to do with the summertime and wintertime temperature change. But the sway the magnitude of up and down is greatly reduced. So the red line shows the 1 meter soil temperature, right? It's it can be as low as 13 degree and can be as high as 25 degrees Celsius. Okay, so wintertime roughly 13. I mean summertime roughly 25. And once you get deeper, this is the dashed black line, and then the magnitude of change is reduced even further, right? So the winter time is roughly 15 degree, and the winter time is roughly 23. So as you go even deeper, for example, in this case, it's the 4 meter deep, right? And then we get this blue dash line. So we can see it's relatively steady. So we got this impression, I mean, common sense understanding, right? As you go deeper to measure the soil temperature, and then you get a steady, almost a steady state temperature, right? Why, right? And that's the question. So when we look at the Earth, I mean, then we see that there's a water table, where's the top line of the saturated water zone, right? And so, and quickly we understand that it's because of the water mass. Water mass underneath the water table, right? Basically, it's the water create the act as the thermal mass, and because there's massive water and the temperature there is relatively steady, and yeah, that's what we call the low temperature geothermal, right? And because of the water content, yeah, so as you go deeper, you have more water content, right? The soil is more, has more water molecule. So because of that, right, the water create that steady state, and that explained why the huge difference when we measure the water, right? I mean the soil, right? The water molecule in the soil versus the air, right? Yeah. So as we can see, the water content in the soil actually stabilize the temperature. Yeah. So of the soil. So and that's the reason it is important that we get that kind of water mass underneath the greenhouse. So let's look at another. This is the infrared imaging. I found this is for the so-called Chinese passive solar house, solar greenhouse. Okay, Chinese version. When we say Chinese version, normally represent you have the very wide opening, covering. I mean, in this shape, facing the sun, right? And and then you have a vertical wall, and then some slope on the north side. So this shows clearly that during a clear day, when we have a good sunshine, and the sun shines through, right, and heat up the air inside. And this is, remember, this is a single layer greenhouse, and then obviously it heat up the air inside. So because of that, hot air rises, right? So we see the hottest spot is at the top, at the tip, inside of the greenhouse at the highest point, right? And this is the bigger the infrared imaging 305. I don't know how it relate to the temperature, but that shows you know, this is the highest spot, and then as you go lower, and the temperature you know, decrease, right? And as you go to the ground, and the ground is you know, show in as a light blue zone, right? So this clearly shows that in the hot, clear day, you know, the sun shines through, you know, heat up the air, and the, you know, top portion get, you know, hot air rises, and so it's higher, you know, on the top, and lower on the ground, right? And this is the reason why we need the water spray. That's why we put the sprayer at the top. So when you have a lot of sunshine coming, you know, bring up the solar thermal heat, and then we use this water to spray the top, so cool down the top area, right? And then bring the collected heat to the ground. Yeah, and this is the clear night. The clear night, we don't have the solar gain because the sun has set, right? And then we have basically thermal loss, right? But it shows the because of the thermal loss, so now the hottest area is the ground. You see, as you can see here, and then there's a balance area, you know, slightly above the ground. But the hottest air, the hottest zone is still the ground. In the case of a cloudy day, it's the same situation, right? We still have some relative hot air above, but because it's cloudy, we don't get much solar gain, right? And as a result, the ground acts, you know, shows to be the hottest area. Yeah, because the water content, right? The solar, I mean, thermal heat collected in other times. So basically, it shows that the ground is the hottest area, and also in the cloudy night, right? By the way, this is relative temperature. Okay, this is showing in the, you know, a certain time, you know, the relative temperature zone, right? It's not the absolute temperature, but it's a relative temperature. But it gives us, you know, the impression that it's the ground, right? It's the ground acting as the thermal storage area, right? It stores the thermal heat, right? Because of that, and it shows that the area to be the hottest spot. So that gives us the impression, right? What if, you know, give us the impression that we tend to think the north wall to be the one that we can use to, you know, absorb the solar thermal energy and contain it. But this images, you know, this infrared imaging clearly shows that it's not the north wall, right? Or the north wall can act can contain some you know, solar energy, but it's mainly the ground. Okay, it's mainly the ground underneath the greenhouse that you know, contain, you know, shows that, you know, this is the hottest area. And then so when you try to understand the whole thing thoroughly, then we have a question, right? Why don't we create a pond, you know, right underneath the greenhouse? And then this way we have the massive thermal mass, enough, you know, great body of water. And then because we create that pond using pond liner, the water won't, you know, sink in, right? Sink through the soil, into the deep into the soil, right? So we contain the water, right? Basically, we contain the water, then we contain the water thermal mass, right? The energy, the heat is stored inside the water. So that's the idea. That give us the idea that why don't we mainly create a pond using pond liner. So we create this a pond right underneath the greenhouse, and then that water is stay there, right? Won't sink through because we use pond liner to create that water mass. And then we believe that because of this, we can contain the water and contain the heat inside. So if we have insulation around the around and at the bottom of this pond, then the heat storage effect is even better, right? And that explains why we we use this picture to depict the PyraTENT we create, right? We design. So so this shows that we use the black black layer. That's simply a pond liner, and then supported by, we can use chain link fence to create that structure, and then attach insulation material, insulation board on both sides, and to insulate this area from the soil. So this way we keep the loss of the heat stored to be to a lesser extent, right? So basically this way we create a pond using pond liner, and then we can use this to contain a massive amount of water, and then create the thermal mass we need. And then we simply, in this case, we simply use a pump, bring the water to the top, and then spray and create the mist and create the water film. And this way we cool both area. We cool the double layer cavity. We also cool this structure, this pod, inside as well, because once you run water, right, on the top surface of the inner layer, and then you cool down the the double layer cavity, right? But also you create a low temperature zone, right, around the entire perimeter of the pot of the this type of greenhouse. So that's why and because of this, the hot air inside, right? Because we all understand that once you enclose create an enclosed structure, and then you have the sun, and then you have the hot air, right? But once we spray the water and create a water film in this way, and then it create a colder layer, which is controlled, the temperature is controlled by the water, right? And because of that, condensation will take place, and as hot air condense, it release heat, right? And then then the heat will release heat into a liquid form, right? And then the heat will bring and the liquid fall down, right? Fall down along the underneath side of the inner layer, right? And then fall down and flow into this thermal mass. So as you can imagine, there's two flow of water. One is the pumped water, you spray to the top and flow down, and then also the water water film on the top side create lower the temperature of the film, right? And because of that, water condense underneath the layer, and then because of that, so we're gonna see two streams of water, right? Obviously, there's more water on the top side and less water on the under side. Right? It depends on the moisture inside. So basically, we simply use water to cool the entire perimeter of the greenhouse, entire envelope, right? And then we bring the thermal energy into water and store in the water. So this is why we say it's a PyraPOD with SolaRoof. It's the two combined, right? We create a pond, right? Yeah. So to contain water. So this way, the water is completely contained inside this structure. So there's you won't have the loss through evaporation because this is a sealed, enclosed environment, and then you won't lose water through sinking, right? Sinking through the soil because you create this pond through a pond liner. Right? So as a result, we believe having a large quantity, like a pound scale water mass, is so critical in adjusting the temperature and humidity of this of this building. So hopefully you understand what I'm talking about, and then that's why we design this PyraTENT this way. So you can quickly use some frame to set up something like this, and to prove it, right? To show, right? To demonstrate and to learn how this thing happened, right? This is why we designed this one without any bubbles. So by eliminating the bubbles, we hope that we help you understand how this thing works. In the region, there's no water freezing happening, and then you don't have to use the bubbles, right? Because you can use the water to bring up the same effect. So this is it. Hope you like it. And then, but the last question is this: once we have this pool of water, occupying the entire bottom of the of a pod, or you can call it a new type of greenhouse. But the problem is then the conventional farmer won't understand. Now we don't have soil to use, right, to grow anything, right? For that question, that's why we need to bring up the aquaponics into the picture, right? With the aquaponics, you don't use the ground, to grow anything, right? With aquaponics, you use the ground to place the fish tank, right? So in this case, we can simply use create another pond slightly smaller than the first one, and then we can then fill water, fresh water inside, and then grow fish. So that inner pond act as a fish pond, while the outer pond, right, control the humidity and temperature of this type of building, right? So that's the idea. So this way we can use the lower portion, create a platform, and then create a pond inside, and to be the fish pond, to be the fish pond to grow fish, and then on top of the platform we can use grow bed, sandbag, and other type of vertical growing mechanism to grow vegetable. So that's the whole idea, right? So if you come from the conventional soil-based grower, then you may have to struggle, right, to understand the whole idea, because you tend to think, oh, I always need soil, right? No, you don't have to, right? Aquaponics is a proof that you don't use soil to grow vegetable. You can use sand, yeah, use other means, right? So anyway, this is the whole idea. I hope I explained clearly, and hope this inspires you to have a new understanding about how to create a better greenhouse, right? A greenhouse with, a pound scale water mass, to be, it is really a water pound, right? And then use that thermal mass to create the steady state, the baseline for the greenhouse, for this type of structure. So using the sun as the heat source and the water as the heat sink, right? And then we can create a controlled environment. The water and the temperature and the humidity can be under control. So this is the whole idea. I hope you get it, and understand it, and then build it, right, to prove, right, it was truly works. So that's it. Hope you like this video, and make sure you subscribe, and so we can create more videos as we build ourselves, and as we develop product based on Richard Nelson's SolaRoof technology.